everyone, today we are going to learn how to graph linear inequalities in two variables, and we're also going to learn how to graph a system of linear inequalities. Before we get started, I want to practice a small skill, and that is solving for y when given an equation in standard form. So what we have here is 4x plus 3y is equal to 9, and negative 2x minus 5y is equal to negative 10. I would like you to please pause the video and solve each equation for the letter y. And when you have an answer, please go ahead and restart the video and we will see how well you did. Okay, so in order to get y alone, that means that we need to bring the 4x term to the other side. So I'm going to subtract 4x on both sides, and I end up with 3y is equal to negative 4x plus 9. At this step, I'm going to divide every single term by 3, and I end up with y is equal to negative 4/3 x plus 3 as my first equation. What we just changed this equation to is slope-intercept form. So now I have this in the form of y equals mx plus b, and that's going to really come into play in this lesson. Let's go ahead and look at example number 2. For example number 2, I'm going to add 2x to both sides, and by doing that I end up with negative 5y is equal to 2x minus 10. At this step I'm going to divide every single term by negative 5, and I end up with y is equal to negative 2/5 x plus 2. So like I just said, it's very important that you know how to change equations that are linear equations that are written in standard form into slope-intercept form, because we're going to be doing that in today's lesson. We're going to be graphing a lot of linear inequalities that are very similar to linear inequations in the way that they are written, but we're going to be writing those inequalities in slope-intercept form and graphing them. So our learning objectives for today are for you to be able to say, I can graph linear and absolute value inequalities, and I can identify the region of possible solutions. So that region is going to become very important. So for today's lesson, I am going to use color. I have 2 different highlighters that I'm going to be working with, and I recommend that you have a couple of highlighters or a pen and a pencil, something for you to use for today's lesson. The other learning objective is for you to be able to say, I can use linear inequalities to solve real-world problems, and I can graph a system of linear and absolute value inequalities. So we're going to be graphing systems of linear and absolute value inequalities. So having the skill of graphing absolute value functions, that's still going to come into play in this chapter, or at least in this lesson. Okay, so let's go ahead and remind ourselves of a few things. A linear inequality in 2 variables can be written in one of these forms. Either ax plus by is less than or equal to c, ax plus by is less than or equal to c, or ax plus by is greater than c, or ax plus by is less than c. So the only thing that's really changing is our inequality symbol. It's either going to be a greater than or a less than. It's either going to be equal to or simply not equal to. Now, when we graph these, we're going to graph them just like we do y equals mx plus b, but the type of line that we graph is going to be different. It's either going to be a closed line or an open line, just like we had closed circles and open circles. And our solution is not going to be just any point on the line. It's going to be part of a shaded region. So I'm going to start off by saying an ordered pair that we call xy is considered a solution of a linear inequality in 2 variables if the inequality is true when the values of x and y are substituted into the inequality. So when we graph inequalities, the numbers that are on the line may or may not be solutions depending on what type of inequality we have, but there's going to be a ton, infinite amount of solutions depending on the shaded region. So in order to test whether or not an ordered pair works, we need to plug that ordered pair into our inequality to see if it produces a true statement. So in example number 1, it says, which ordered pair is a solution for 5x minus 2y is less than or equal to 6? So I'm going to substitute 5 into this inequality by letting x equal 5 and letting y equal 5. So I'm going to write 2 times 5, I'm going to write 5 times 5 minus 2 times 5. Is that less than or equal to 6? Is 25 minus 10 less than or equal to 6? Is 15 less than or equal to 6? Why, no, it is not. So what that means is that 5 is not a solution. So I can say not a solution. A solution means that you'd be able to produce a true statement, and 15 is not less than or equal to 6, so it is not a true statement. Next, I'm going to let x equal 1, and I'm going to let y equal -2, and I'm going to plug it into my inequality by writing 5 times 1 minus 2 times -2. Is that less than or equal to 6? Is 5 plus 4 less than or equal to 6? Is 9 less than or equal to 6? Why, no, it is not. So once again, 1 -2 is not a solution. Let's go ahead and look at letter C. Letter C, I'm going to write 5 times 0 minus 2 times -3. Is that less than or equal to 6? Is 0 plus 6 less than or equal to 6? Why, yes, 6 is indeed less than or equal to itself. That equal to means that it would actually work. So 0 -3 is a solution. It's not the solution, but it is a solution. It actually does work. And let's go ahead and look at 3. I'm going to write 5 times 3 minus 2 times 3. Is that less than or equal to 6? Is 15 minus 6 less than or equal to 6? Well, once again, 9 is not less than or equal to 6. So in this case, 3 is not a solution. The amount of work that I showed is right around the amount of work that you're going to need to show when you do your homework. If you showed the substitution and then went straight to this answer showing that 9 is not less than or equal to 6, that's enough work that you need to show. But always show the substitution into the original problem. Next, we're going to graph linear inequalities. So the graph of a linear inequality in 2 variables is the set of all points in the coordinate plane that represent solutions of the inequality. So in order to identify those solutions, they're going to be part of a shaded region. So what we have here is a graph of a linear inequality of 3x minus 2y is greater than 2. And you're going to see shading. Every single ordered pair in this shaded region are solutions. The dashed line, as well as the unshaded region, are not solutions. So this is dashed line and unshaded region. They are not solutions. Now, the line that divides the plane into 2 halves, that is called the boundary line. That line comes from y equals mx plus b. And that's one of the reason why I had you guys practice the skill in our warm-up. Because we're going to be graphing lines. Now, the boundary lines will either be solid or dashed. It just depends on what type of inequality that we have. Solid boundary lines are going to be used for less than or equal to or greater than or equal to symbols. Excuse me. Think about whenever we graphed on a number line, open circles or closed circles. We would have a closed circle on a number line if we had a less than or equal to or a greater than or equal to symbol. So we would draw a solid line. Now, are the points on the boundary lines a solution? The answer is going to be yes. They are going to be solutions. So if you have a solid line, all of the points on that line would produce true answers. Next, it says use a dashed boundary line if you have a less than or a greater than symbol. Because if we were to graph greater than or less than on a number line, we would have an open circle. Same thing with lines. We're going to have an open line. And are the points on the dashed boundary line solutions to the inequality? Why, no, they are not. They would produce false statements. So they're not included in the solution set. Solution set. So paying attention to the symbol is going to become very important. So how to graph a linear inequality? To graph a linear inequality, you need to follow these two steps. Step number one, you need to graph the boundary line. You need to make sure that you determine if the line should be solid or dashed before you graph it. Step number two, you're going to need to test a point that is not on the boundary line, so not on the boundary line, to determine whether it is a solution of the inequality. If the point is a solution, then shade the half plane containing the point. If the point is not a solution, then shade the other side. Shade the other half plane. This lesson is going to be, for those of you who do not like to draw your lines extending the grid, it is very important for you to get into the habit of drawing your lines that extend the grid, because you're going to need to identify what your half planes are. So let's go ahead and look at the first example. For this first example, this is x is less than or equal to 5. This is a VUX situation, a vertical line, undefined slope, x equals a number. So I already know I'm going to draw a vertical line. The next thing I need to decide, is this going to be solid or dashed? And because I have an equal to symbol, I know this is going to be a solid line. So at x is less than or equal to 5, so I'm going to go to where x is equal to 5. 1, 2, 3, 4, 5. I'm going to plot a point. And then I'm going to use a straight edge to draw a vertical line. So you're going to need a straight edge for this lesson. So if you need to pause the video to get yourself a straight edge, then that is fine. And I'm going to draw a straight vertical line that extends the entire grid. And now I just need to pick a point. You can pick any point. I say pick an easy point. I'm going to select 0, 0. 0, 0 is not on my line. And in choosing the point 0, 0, I only need to use the x value. And I have to ask myself, is 0 less than or equal to 5? Well, yes, it is. So I am going to pick a color, and I am going to shade on the side that 0, 0 is in. And there is my solution. Let's go ahead and look at number 3. For example, number 3, I have y is greater than negative 2. Well, this is a Hoy situation. Horizontal line. Y is your 0 is your slope. Y equals a number. And in this case, because I have a greater than symbol, this is going to be an open circle. I'm sorry, an open line or a dashed line. So I'm going to go to where y is equal to negative 2. I'm going to plot a point, and then I'm going to draw a dashed line going through that point. Make sure your dashed line looks like a dashed line and not just a line with maybe a couple tiny spaces. Make your answers deliberate. Now 0, 0 is not on the line, so I'm going to use that point to test. So selecting 0, 0, I only need to use the y part and say, is 0 greater than negative 2? Well, yes, it is. So on the region that has 0, 0, which is up here, I am going to shade the plane. All right, let's go ahead and look at example number 4. For example number 4, I have y is greater than negative 3x. So in this case, my slope is negative 3, my y-intercept is 0. So I'm going to start at 0, 0, and then I'm going to go down 3 to the right 1. And I'm going to come up with a couple of points on this line. And in this case, this line is going to be dashed because I have a greater than symbol. So it's either dashed or open. It depends on how you want to view it. If you want to view it as an open line, that might be a good thing. If you want to view it as a dashed line, that's fine too. All you need are a few points on that line in order to graph. So I have 3 points. That's good enough for me. And I'm going to draw a dashed line going through those points, extending the entire grid. Now, unfortunately, in this problem, 0, 0 is on the graph. So I need to pick a different ordered pair. Pick something that's easy, like 1, 1 or negative 1, 1, something that is easy. And I can see that 1, 1 is right here, and it is not on the line. So I'm going to choose 1, 1, and I'm going to test to see if it works in this inequality. Is 1 greater than negative 3 times 1? Is 1 greater than negative 3? It is. So where 1, 1 is located, I'm going to shade that region. Next, I'm going to look at number 5. For number 5, this is written in standard form, and I would recommend that you either work with the intercepts or you change it to y equals mx plus b. So I'm going to change it to y equals mx plus b form, slope-intercept form, and I'm going to be very careful with my signs. So I have 3x minus 2y is greater than negative 6. I'm going to subtract 3x on both sides, and I end up with negative 2y is greater than negative 3x minus 6. I'm going to divide every single term of this inequality by a negative number. And I know that if I divide by a negative, I'm going to switch the direction of the inequality to make this y is less than positive 3 halves x plus 3. This line is going to be dashed because I have not an equal to, and so I'm going to check my answer. So I'm going to go to, when I check my answer, I'm going to graph this, excuse me, before I check my answer, I'm going to graph this going up to 3, 1, 2, 3, and then my slope is 3 over 2, so I'm going to rise 3 and run forward 2, rise 3, run forward 2, and I have a few points, and I'm going to draw a dashed line going through these points. And then I'm going to pick a point to test. I'm going to make sure that my line extends the grid so I can clearly see my 2 different sides. And what's really nice about this problem is that it goes through 0, 0. Or sorry, it does not go through 0, 0, so I can use 0, 0 as a test point. Now you can test your point through the equation or the inequality that you came up with, or you can test using the original. It depends on what you want to do. So I'm going to test using the original, and I'm going to test 0, 0. And I'm going to write 3 times 0 minus 2 times 0. Is that greater than negative 6? Is 0 greater than negative 6? Why, yes it is. So the side that has 0, 0, that's going to be the side that I'm going to shade. Cool. Now let's go ahead and look at example number 6. Example number 6 has an inequality that is an absolute value inequality. You're going to graph this absolute value just like you did in the past. You're going to identify what your vertex is and then apply the slope of the right-hand side, reflecting those points on the other side. So in this problem, our vertex is the opposite of what we see inside. It is going to be a 1, and exactly what we see on the outside, which is a 2. So we're going to start with 1, 2, and then the slope of the right-hand side is going to be negative 2. And then I need to decide, am I going to draw dashed lines or solid lines? And because this is a greater than symbol, I'm going to have a dashed line, or the word open, if that helps as well. So I'm going to go to where 1, 2 is, and I'm going to go down 2 and to the right 1, and come up with a couple of points, and reflect those points on the other side, and I'm going to draw dashed rays coming off of the vertex, extending the entire grid. In this problem, 0, 0 is crossed, so we cannot use 0, 0. So we need to come up with a different point. So I'm going to recommend that we choose negative 1, 1. It's located over here, and it's on the outside. So the boundary regions is either inside of the V or outside of the V. So I'm going to check the point negative 1, 1. Now, you can pick any point that you want. If you wanted to pick 1, negative 1, you absolutely could. It just depends on what you want to do. And I'm going to plug this ordered pair into the original problem. So I'm going to write 1, is that greater than negative 2 times the absolute value of negative 1 minus 1 plus 2. So I have, is 1 greater than negative 2 times the absolute value of negative 2 plus 2? Well, the absolute value of negative 2 is 2. So this is 1 greater than negative 2 times 2, changing the absolute value to a parentheses, plus 2. Well, negative 2 times 2 is negative 4. So I have, is 1 greater than negative 4 plus 2? Is 1 greater than negative 2? And it is. 1 is greater than negative 2. So the region that I'm going to shade is the outside of my V. So remember, there's an inside of your V and the outside of your V, and I'm going to shade the outside. And here is my answer. All right, let's go ahead and move on to the next page. For problem number 7, it says you have 2 part-time summer jobs, one that pays $9 an hour and the other that pays $12 an hour. You would like to earn at least $240 a week. It says write an inequality describing the possible amounts of time you can schedule at both jobs. So on here, I want you to make sure that you can clearly see what the lines are. It says 10, 20, 30, right here is 40. And then this is going by 5s. So that's important for you to see that. And then I know you can't tell up here, but I want you to think about this going by 5s as well. So this is going to be 10, this is 20, 30, 40, and up here is 50. And this is going by 5s. So just to make sure that we're on the same page. Okay, so the first thing it says is that we want to write an inequality describing the possible amounts of time that you can be scheduled at both jobs. So the first thing that we need to identify is we need to identify what our unknowns are. We need to know, it says you have 2 part-time jobs, one that pays $9 an hour and the other pays $12 an hour. And it says you would like to earn at least $240 a week, and we want to figure out, write an inequality describing the possible amounts of time. We don't know time. We don't know how many hours we need to spend at each. So those are going to be our variables, and you always need to identify and label your variables. So X is going to represent the number of hours at the $9 an hour job, and Y is going to equal the number of hours that you spend at the $12 an hour job. So we've established our unknowns. And you're going to be paid $9 per hour at the first job, plus $12 per hour at the second job, and we want to earn at least $240. So at least is kind of one of those tricky phrases. At least means that you want to earn minimum $240 or more. So I'm going to write a little star up here, and I want to say that if you see the word at least, that symbol is automatically going to be greater than or equal to. And if you see the word at most, that's automatically going to be less than or equal to. And this is really going to come into play in our next lesson, which is about linear programming. So I have 9x plus 12y. That needs to be greater than or equal to $240 because we want $240 to be the minimum amount that we're going to make. So to graph this inequality, I would recommend that we change this to y equals mx plus b. So I'm going to use that on the side right here. And I'm going to start off by subtracting that. So I'm going to write 9x plus 12y. That's greater than or equal to 240. I'm going to subtract 9x on both sides, and I have 12y is greater than or equal to negative 9x plus 240. I'm going to divide every single term by 12, and I end up with y is greater than or equal to negative 3/4 x plus 20. Cool. So I'm going to go up to 20, which is right here, and I want to go down 3 and to the right 4. So going down 3 and to the right 4, because my scale is both going by 5s, I can count going down 3 and to the right 4 and be okay. If my scale were different numbers, then I'd have to be a little bit more careful. So starting right here, I'm going to go down 3 units, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Okay. So now I'm going to draw a line going through these points. Okay. I didn't do a very good job on that, huh? There we go. Sorry about that, guys. There we go. There we go. Now it says identify 3 solutions of the inequality. Well, solutions. We need to come up with the shaded region. What values would make the most sense? Okay, so let's first of all test 0, 0, just to see if that's part of it. So if I were to test 0, 0, I would say, is 9 times 0 plus 12 times 0 greater than or equal to 240? Well, 0 is not greater than or equal to 240. That's not true. It's a lot smaller than 240. So the area that has 0, 0 is not going to work. So I'm going to shade the other region. So now I'm going to identify 3 different solutions. And 3 different solutions would be any ordered pairs that are part of the shaded region, like 30, 30. 30, 30 is right here. If you work 30 hours at one job and 30 hours at the other job, you would earn more than $240. 40, 40 would be another example. And another solution would be like maybe 25, 25. So 25, 25 would be like right here. So that's 3 solutions that would absolutely work within the shaded region. All right, we have one more topic, and that is how to graph systems of linear inequalities. So now that we've learned how to graph inequalities, or at least reminded ourselves of how to do that, we're now going to graph systems. And we know that systems means that we're going to be graphing more than one on an actual grid. So to graph a system of linear inequalities, the first thing you're going to do is you're going to graph each inequality in the system individually. You may want to use colored pencils to distinguish the different regions. So I used highlighters, but I would prefer colored pencils or highlighters or some sort of color. You pick the color that you're going to use, but I would prefer some kind of color to distinguish the different regions. Step 2, I want you to identify the region that is common to all of the graphs of the inequalities, the overlap. This region is the graph of the system, and if you use colored pencils, the graph of the system is the region that has been shaded with every color. So it's your overlap of all of the colors, and that's going to be considered your solution of the graph. So let's go ahead and look at example number 1. So I'm going to graph each system or each inequality individually. Starting with the first one, I have y is less than 2x plus 1. This is going to be dashed, so it's important to know what type of line you're going to draw before you draw it. I'm going to go up to 1, and then I'm going to rise 2 and run forward 1 and come up with a couple of points on that line. I'm going to draw a dashed line going through those points. And it appears as if 0, 0 is not on this line. It's over on this side. So I'm going to check 0, 0. And I'm going to say, is 0 less than 2 times 0 plus 1? Is 0 less than 1? It is. So therefore, I'm going to shade this side of the region. If you're working with colors, start with your lightest color and then work your way to darker. Next, I have y is less than or equal to negative x minus 3. This is an equal to, so that tells me this is going to be solid. So I'm going to go down to 3, 1, 2, 3, and I'm going to plot a point, and then I'm going to go down 1 and to the right 1, applying my slope, and I'm going to draw a solid line going through these points. Next, 0, 0 is not on this line, so I'm going to check 0, 0. And I'm going to say, is 0 less than or equal to negative 0 minus 3? Is 0 less than or equal to negative 3? No, it is not. 0 is actually bigger than negative 3. So that tells me that my shaded region is going to be below. It's going to be on this side. You can shade everything, but the real answer is going to be down here. That's where the overlap is, but you can shade everything if you would like. Your solution, though, is just going to be the overlap. It's just going to be right here where these two colors intersect. That is your answer. Let's go ahead and look at example number 2. For example number 2, we need to graph each line individually. So I'm going to start off by saying that we have y is less than or equal to negative 3/4 x plus 1, and this is going to be a solid line. So I'm going to go up to 1, and then apply my slope going down 3 and to the right 4. And I'm going to come up with a couple of points. On that line, and I'm going to draw a solid line going through those points. 0, 0 is not on my line, so I'm going to use that to test, and I'm going to say, is 0 less than or equal to negative 3/4 times 0 plus 1? Is 0 less than or equal to 1? It is. So that tells me that the side that has 0, 0 is going to be a part of the shaded region. So I'm going to work with my lightest color first and shade. Now I'm going to graph 3x plus 4y is greater than 16, and I'm going to solve for y on the side. So I have 3x plus 4y is greater than 16. I'm going to subtract 3x on both sides, and I end up with 4y is greater than negative 3x plus 16. Dividing every single term by 4, I end up with y is greater than negative 3/4 x plus 4. So I'm going to go up to 4. Plot a point, and then I'm going to go down 3 and to the right 4. Down 3 to the right 4. And this problem, because it's not an equal to, this is going to be a dashed line or an open line. It's always important to know what you're going to draw before you draw it. All right. Next, I need to test a region. So I'm going to test 0, 0. Once again, 0, 0 is not on my line. So I'm going to see, is 3 times 0 plus 4 times 0 greater than 16? So I'm just plugging in 0, 0 back into the original problem. And is 0 greater than 16? No, it is not. It is not bigger than 16. So that tells me I'm going to shade in the other region. So my other region is going to be up here. It's on the side that does not have 0, 0. In this problem, there is no overlap. We have two parallel lines that are separating the gap, and in this case, this is considered no solution. The shaded regions do not intersect. So because they do not intersect, this is considered no solution. There doesn't exist one ordered pair that would work for both inequalities. We have one more example and then we are finished. Next, we have y is less than or equal to 4. So this is a Hoy situation and it's going to be shaded, a solid, it is going to be a solid line. So I'm going to go to where y equals 4. 1, 2, 3, 1, 2, 3, 4. And I'm going to draw a horizontal solid line. I'm going to pick 0, 0, and I'm going to ask myself, is 0 less than or equal to 4? Why, yes, it is. 0 is smaller than 4. So that means that on the side that has 0, 0, I'm going to shade. Next, I'm going to graph my absolute value equation by first identifying my vertex. In this problem, the vertex is located at 2, 1. It's the opposite of what we see inside and exactly what we see on the outside. And my A value in this case is the number 1. It's an invisible number on the outside of the absolute value. So I'm going to go over to where 2, 1 is and plot my vertex. And then I'm going to apply the slope by rising 1 and running 1. This is an inequality symbol that is not equal to. So that means that I'm going to have a dashed line. So my V is going to be dashed. At this step, we need to pick a point. There's two regions. There's either inside of the V or there's outside of the V. And I'm going to once again check 0, 0. And I'm going to see, is 0 greater than the absolute value of 0 minus 2 plus 1? Is 0 greater than the absolute value of negative 2 plus 1? Is 0 greater than 2 plus 1? Well, is 0 greater than 3? No, it is not. So it doesn't work. So the side that has 0, 0 will not be shaded. And that means that only this little tiny inside piece of the triangle would produce ordered pairs that would actually work. So I'm going to shade the whole region that works for my absolute value. But I'm only interested in the overlap. And the overlap in this case is right here. Those ordered pairs are the only ordered pairs that would actually produce solutions that work. Ladies and gentlemen, that is the end of this lesson. If you have any questions on how to graph linear inequalities or systems of linear inequalities, please feel free to email me. Otherwise, I hope you have a wonderful day.